Hello everyone and welcome to our on-demand webinar, Controlling Risk by Reducing Human Error. Our presenter for this webinar is Doug Robey. Douglas Robey is the Vice President of Maintenance and Training and Reliability at GP Strategies. With over 20 years of experience in adult learning and maintenance training consulting, Mr. Robey oversees the strategic approaches and successful launch of performance improvement projects, services, and sales in multiple market sectors, including energy, manufacturing, electronics, semiconductor, steel, oil and gas process, and others. And with that, I welcome Doug Robey.
All right, good morning. Thanks, Eric. The main area I'd like to discuss this morning is tying in the human element side to the reliability process. Many companies we work with in the past either focus on one or the other. Our goal here is to try to tie the two together. Many times companies focus heavily on the process side and even on the reliability side, but they forget to train their people. So part of this conversation is really focusing on both. You need to tie the human element side to your reliability process. And what we found three main dilemmas that usually cause this effect. One is periods where crews may be understaffed and overloaded, the need for an influx of new skilled trades personnel who will initially be unfamiliar with particular systems, equipment, procedures at a facility, and most important, training not tied to your maintenance reliability program. The impacts that you'll see from this is you'll see periodic understaffing, reliance on your senior people, more work at a higher pace, a lot of increased overtime. Your contractor price will increase because you don't have enough people for the work. Your backlog increases. You have PMs that are being skipped. You're going to have much more reactive work, no time to work on your proactive task, and reliability suffers. So when we talk about the influx of new workers, a lot of times people do carry Joe's toolbox, and it doesn't really work. They're not familiar with your processes. They may be taught bad skills. The potential for safety problems occur. They don't understand failure modes. These are all factors when you bring new personnel in and they're not trained properly to your reliability process. So what we find also is people then they panic and they want to do training right away. And it's been known that 80 to 90% of most training is ineffective. And that's because it's not tied to the proper process that you need to be trained on. It's not job related. They throw something against the wall and hope it sticks. It's not tied to the reliability process, to your business drivers. You bring in the wrong people to do your training, and it doesn't tie effectively to what needs to be done. Our experience is having your training, your skills, everything tied to your manufacturing process, to your reliability process, understanding how defects get into your system, how it can fail, we feel is very effective. So what we put together is really a reliability process very similar to the RCM process. A lot of facilities, a lot of companies use this process, but what we've done is we've tried to tie the human element to the end on this. So just like other RCM type processes, everything's important. The asset data, the registry, the criticality, setting up the right strategies, executing the work, optimizing the work, we feel is all very critical to the process, but making sure that the human performance side is tied to the process is really what ties everything together and makes your program successful. Many companies have put a reliability process in place, but have failed miserably because their people either don't understand, aren't on board, aren't trained properly, or the documentation's incorrect. So as you can see in our flow chart here, we try to tie everything together from the human element side back into the reliability process. So not only your maintenance people, your operations people need to be on board, your planners and schedulers, supervisors, everybody should understand your process. Everybody should understand if there's an issue in your process, how is your root cause process, your continuous improvement tied back in to fix problems once you find them and get them back into the system, to better utilize your program, and to train your people afterwards. Once we have a process in place, a reliability process where we got everything working, how do we assess and train our personnel? There's many ways it can be done. Benchmarking can be done, how companies do it. You can assess your personnel, and ways that we've worked in the past is coming in and assessing your personnel to see where they fit on the reliability path of training. So what we look at is, based upon your critical equipment and your defects, what is your plan as a company? How do you take care of that? What processes do you have in place? From that, we can develop surveys, we can develop job and task analysis to put into an assessment, either short-term, long-term. Short-term, we want to look at areas for quick improvements, and then long-term, we want to look at what are the actual skills you need from a new hire coming in all the way to a top journeyman or a top operator. From that, we can develop hands-on assessments, we can develop written assessments for the short-term fix, and then for the long-term, we can actually find all the tasks and develop a program that is really critical to your process down the line. So when we talk about long-term initiatives, OJT is a great way to handle this. A job and task analysis for these initiatives work well, whether it's a new line, whether it's new employees coming in. So coming in, understanding the equipment, developing the procedures if they're not there, and then identifying all the tasks to be used for the assessment, and then we can develop the task for the OJT for your facility or company. Based on that, at the end, you'll have a structured OJT process that not only identifies the critical task that a person is doing, we can actually measure against that so you know they're actually doing the right task on the right piece of equipment based upon your reliability process. For other means, we can determine your existing workforce. We can provide surveys for the skills. So the surveys that we send out, your facility or company can check this off. Yes, we do this type of work. No, we don't. It's not applicable. From this, it gives us an idea of how to develop a database for skills that we then can assess your personnel on. And at the end of that assessment can give you a starting point of where training really needs to begin. And from that, we want to make sure that whatever assessments are made, that they are tied to your reliability process, they're tied to your actual equipment, and tied to the precision maintenance skills that your facility or company needs. They need to be objective-based, not just very, very generic. And then there's multiple ways we can conduct those assessments. They can be online, they can be paper-based, and they even can be hands-on tasks that can be provided. The bottom line is understanding what your goals are, what type of ROI that you're looking for, where are your issues, and then coming up with the right custom solution to tie your training to your reliability process. And then we talk about skill performance measures. This is the hands-on component of an assessment. What we try to do is we find out what are the critical skills. Is it alignment? Is it troubleshooting? What are the important hands-on skills that you want all your personnel to have? It's very important to have all your maintenance or even operations to a certain level when it comes to installing equipment, doing maintenance, troubleshooting. So that way, from a reliability process, everybody's doing standardized work. It's not being done in different ways. So what we look at are what are the tasks, critical tasks and skills that need to be done. From a hands-on standpoint, what type of tasks do we want to do? And the bottom goal is to have them actually perform the task. That's the most important thing. So we have people that do struggle with taking written tests, so the hands-on performance is a way to do an actual assessment on them for their actual skills. And this all is part of our training model. We have a pyramid approach from a foundational up to an advanced fundamental process. We can assess from basic math, basic electricity, and then go all the way up through customized critical equipment. What we do is we bring to the table multiple basic courses from online to hands-on through our catalog, and then through the applied fundamentals where we can actually bring the equipment in and test your people or provide training on the actual equipment. And then the final phase is the customized part on your critical piece of equipment. We can work with OEMs, we can work with your SMEs to develop either the hands-on portion of an assessment or even the hands-on portion of an OJT. And then the final element is tying in safety and quality aspects to your program. And then a big part of the process tying into reliability that people often sometimes forget is the operations side. The operators are the first line of defense and also know the equipment the best. So frontline reliability is a priority in the process of reliability. Having your operators be proactive in doing inspection, providing basic troubleshooting, even changing filters, is really a proactive approach to finding issues and eliminating defects. So having a frontline reliability process we feel is critical in freeing up maintenance to be a more proactive force. So 3 ways reliability relieves maintenance strains. Obviously increases production staff reliance, it aids in backlog management of early identification, and leverages frontline maintenance concepts to balance workload and task. That's important. The goal of reliability is to get away from the firefighting mode and to be more proactive. With frontline reliability, this really gives you a heads up in getting to that, into the focus of proactive maintenance. So for operator-centric programs, it forms a partnership on the shop floor. Many facilities, operations and maintenance aren't tied together. This actually forms a partnership, builds bonds. They work together now, understanding of really a process to how things work, to report defects and abnormalities. 5S and cleanliness standards are vitally important in this process. Identifying what task operators can do, as I mentioned, lubrication, filter change, inspections are all vital tasks that can be done by an operator. Operators can use visual aids, color code gauges, piping, etc. Cleaning goes a long way in helping in the prevention of defects getting in the way of production. It's been proven that this type of process increases production, and it also standardizes work. An operator's not just there pushing buttons, they're actually involved in the equipment, they're involved in the upkeep of equipment and making things run much more accurately, and the uptime increases. And bottom line is it empowers them to be the frontline operators. It helps them in complete maintenance assist and freeing up maintenance to focus on proactive work, to work towards what they need to be doing, improvement of RCM programs, etc. Finally, it's been shown that 80% of all equipment failures are human-induced, meaning that the failure was caused by the actions of people. This can be controlled by the following best practices: determine the correct maintenance plan on critical equipment, follow repeatable, effective PM, corrective, and lubrication procedures, perform all work right the first time, making sure enough time is allotted and work is not rushed, know and follow best repair practices, measure mean time between failure by plant, area, and critical equipment, and post these graphs for all to see. Finally, effective training, continuous improvement lead to long-term success. Bottom line is it's been shown that human performance tied to reliability on the training side is critical. If you guys aren't trained the right way to do standardized, repeatable work, then you're going to have a variance in the work product, and the chances of your reliability process succeeding are minimized. Really, at the end of the story here, that's really the point I want to get across, is make sure that your training is tied back to the proper documentation, is tied back to your reliability process.
Looking at some of these slides, did you have any examples of, where any of this applied to one of our clients or customers?
A good example that I can come up with is we worked with a steel company that had a bearing issue. They were going through over $4 million a year in bearing cost. By doing the proper assessment up front, it was concluded that they were misaligning equipment and installing bearings incorrectly. And this was due to the fact that they had improper procedures in place and their mechanics were not trained properly on coupling, shaft alignment, and bearing installations. So 2 things were done. One, a program was put into place on the critical equipment for installation to make sure that equipment was installed and aligned correctly. And the final part is all maintenance personnel went through a coupling, shaft alignment, and bearing installation course. The result of that was a decrease the first year of $3 million of savings in bearings. So just that one quick impact based on what they found from a critical piece of equipment resulted in a net savings of $3 million. So these are little things, defects, if you track properly, can be fixed very simply, either with critical procedures being or documentation being corrected and then a training program followed by that.
Right. So did you figure this out from an assessment, or how did you figure out that it was the training that was wrong and not anything else?
A lot of it had to do with downtime of critical equipment in some of their facilities that they were finding, and then doing the root cause analysis. It was found that they were actually burning bearings up, and this was due, when we actually went through the root cause, due to vibration occurring because they weren't installing them correctly and they weren't aligning them correctly. So a quick root cause, which is part of your reliability process, which is great, resulted in, hey, we do have an issue here on the documentation and training side, where you come in and you train your people the right way, and going forward, hopefully it reduces in defects in your facility.
All right, great. Well, thank you, Doug. And if you have any questions, you see Doug's contact information on the slide, and please feel free to reach out to him, and he will answer any questions you may have. So, Doug, thank you for taking the time to do this, and we hope to hear from you again. Thanks.
Thank you.